Hey everyone, I thought I would share with you a workflow that I came up with for doing shipping crates. So these are like dovetailed shipping crates. These were made using the Vectric gadget that sort of plunges on Z and then down on X or Y to sort of mill out a dovetail. These make super strong crates. Bill Young turned me on to this. And I've used these for shipping stuff all over the country. And the problem with them is not anything with the crates, but the fact that when I make these things, it's usually at the 11th hour. You kind of don't know the size crates you need until the very end when you're sort of packing everything in. And I've definitely, using the Vectric gadget before, which works, but I've definitely messed this up before by like cutting the wrong pins in the wrong spot, and then when you create the actual dovetail toolpath, it comes up as like an imported toolpath, so you're not able to move it around very easily. So something like this crate here, which was a 3-sheet crate, it makes it a little challenging to kind of rerun that gadget over and over again. So I've been fooling around lately with OnShape, which is this online parametric 3D design tool. I've actually made the crate in OnShape, and basically the way it works is this is not an OnShape tutorial, I'm just going to give you quick headlines here, but you basically design all the parts that you need, each part one by one that goes in an assembly. And the way I've designed these is down the left side here, there's all the variables. So interior height, width, and depth, the angle of the dovetail, the size bit you're going to use to cut it. There's even settings for the top, so you can allow a little bit of looseness in the top, so you don't have to use a pry bar to pull the lid of your crate off. You can have a little bit of friction, but not too much. Plywood thickness, size of the tabs, everything like that. This is all parametric. So let's say I want this crate a little bit deeper, so I just go in here, and this was 32 inches. I'm going to modify it to 40. And if you're keen-eyed here, you'll see that the crate, we'll look at it from the assembly view here. The crate will spin around for a second here, and then it will automatically rebuild itself. So it recalculates all of the dog bones, all of the pins, all of the sizes of plywood, and everything on the fly like this, which is super, super cool. It's very reliable. You can basically build a crate any size you want, probably up till getting to a 4x8 sheet of plywood. In OnShape 2, everything's linked together, so all of those parts link to this drawing. So this is like a layout drawing that shows all of the different parts of the crate, and once it loads here you'll see. And so we've got dimensions of all of the side panels and things like that, and for those that do like to use the Vectric gadget, I've actually set it up here so that this is the dovetail pin width. You can see that there's 0 gap on the bottoms and sides, and then a little bit of gap on the top, and this one shows the dovetail angle. And then if you want to mill these in Vectric, you can go to the front and back. There are different tabs that represent the different parts, and you can just actually right-click these and export them and get a DXF file that you can pull right into to Vectric. So that is a way that I've come up with to more easily do this, but I've actually taken this a step further. So I like milling things in 3D whenever possible, and something like this you can't really mill in 3D. Like, you can't make this in STL and mill it out properly in Aspire. So what I've actually done is I've exported this to a step file and brought it into Fusion 360, which does 3D toolpaths. And you can see here that this is a test cut just to see if all the clearances and everything work out. So I ran these toolpaths, and here are the results. So this is my female, I call this the female dovetail pin. So this was cut in this orientation, so the end mill just plunges like this, and you can see we've allowed a little clearance for a bit here. And this is the male dovetail pin. This one's the top, so this one is the one that I've allowed to have some wiggle room. And you see when we put it together here, it's got a little bit of wiggle room, but in a crate it definitely wouldn't pull, the side wouldn't pull out. But when you get to your destination, you can just take the bolt out and pretty easily take your crate off. This is the one. These are the rest of them that are supposed to be tighter, and I had a little chip out on this piece here, but these ones fit when I first put this together, whack it with a dead blow mallet and it pops right into place, and you've got a nice tight dovetail. So that proves that this this workflow works. But I thought you guys might find this interesting, and let me know if you have any questions.